On August 19, 2004, an explosion at the Sterigenics International Facility in Ontario, California, injured 4 workers and caused extensive damage to the 66,000 square foot facility. The blast occurred when ethylene oxide gas, used in the sterilization process, ignited and exploded. The U.S. Chemical Safety and Hazard Investigation Board investigated the accident.
This was an incident involving a chemical that is both highly flammable and toxic to humans. It is fortunate that no one was in the immediate vicinity of the explosion, because it is likely there would have been more serious injuries and possibly fatalities.
The CSB investigation reveals several factors that led to the explosion at Sterigenics. This video digest is intended to graphically show what happened and how such accidents may be prevented in the future. Sterigenics International uses ethylene oxide to sterilize medical products such as syringes, catheters, and bandages, and then ships them to medical suppliers. Products arrive at the plant prepackaged and stacked on pallets, ready to be sterilized in large steel chambers. The plant contains 8 sterilization chambers, operated and monitored by personnel using a computer system in the control room. Packaged medical products are added to the chamber and the doors are sealed. The chamber is then filled with ethylene oxide, which penetrates the packaging over a period of several hours, killing any germs and sterilizing the products inside. After the sterilization phase, ethylene oxide is removed from the chamber and the packaged products in several steps. First, about half the gas is pumped from the chamber to a pollution control device called a scrubber, where it is removed by chemicals. Next, virtually all of the remaining ethylene oxide is removed in a step called gas washing. This involves injecting air and nitrogen into the chamber where they mix with the ethylene oxide. This mixture is then pumped from the chamber to the scrubber. This process is critical to reducing the concentration of ethylene oxide to below explosive levels and is repeated several times until there is only a trace amount of ethylene oxide remaining. This trace amount of gas is not explosive, but it is toxic and must be removed by ventilating the chamber before workers can enter. The front door is raised a few inches, which automatically opens a vent at the rear of the chamber. Air is drawn through the chamber to another pollution control device called a catalytic oxidizer. Once the air enters the catalytic oxidizer, it is heated as it passes over open flames. Any remaining traces of ethylene oxide are removed as the air passes over a metal catalyst. After the chamber has been ventilated for several minutes, operators can safely enter to remove the products. During the sterilization process, gas washes are key to removing ethylene oxide and preventing explosions. But on the day of the accident, this critical step was bypassed. On August 19, 2004, the computer alerted operators to a possible error in the amount of ethylene oxide that had been injected into chamber number 7. Operators in the control room instructed the computer to abort the sterilization cycle and remove the gas. The system automatically performed the normal series of gas washes, which removed virtually all of the ethylene oxide. Finally, the chamber was ventilated to the oxidizer. Operators then removed the products from the chamber. Maintenance technicians arrived and performed tests, which did not reveal any problems. They then ran a test cycle that injected 120 pounds of ethylene oxide into the empty chamber. And again, they could not identify a problem. As the system performed the first step of pumping ethylene oxide to the scrubber, the technicians asked the supervisor for permission to bypass the time-consuming gas washes. The supervisor agreed. All of them incorrectly believed that because there were no products in the chamber to absorb ethylene oxide, all the gas would be removed in the first step, making the gas washes unnecessary. They did not realize that about half of the ethylene oxide originally injected still remained in the chamber. There was no monitoring system to alert them to this explosive concentration of gas. The supervisor provided a technician with his special computer password to manually advance the cycle, bypassing the gas washes. A short time later, the front door was raised, activating the chamber ventilation system. This drew a large amount of ethylene oxide from the chamber through the back vent to the open flames in the oxidizer. The explosive gas ignited. A flame front traveled back through the ducting, into the sterilization chamber, igniting the remaining ethylene oxide and causing a powerful explosion. It destroyed the sterilization chamber, bulging the chamber walls outward, blowing off both of the 2-ton chamber doors, sending one of them 75 feet away, knocking out this hole in the north wall. The force of the blast caused widespread structural damage throughout the building. The control room was showered with flying glass from the windows. Debris, including the computers that control the process, littered the inside of the room.
While the accident would seem to have been caused by a single event, bypassing the gas washes, the CSB investigation actually revealed several causes for the explosion.
The supervisor with the critical password did not understand why the gas washes were essential, whether the chamber was empty of products or not. Next, the sterilization chamber was not equipped with a gas monitoring system to warn employees of explosive levels of ethylene oxide. And the company's process hazard analysis program never thoroughly evaluated the hazard presented by the oxidizer, despite a history of oxidizer explosions in the sterilization industry.
The CSB investigation noted that the control room had glass windows that were not shatter-resistant. The control room suffered significant damage in the explosion, and all the injuries occurred to workers inside the room.
If your control facility is located in an area where an explosion could occur, consider using reinforced window materials or replacing any windows with video cameras. Another lesson from this incident is the importance of regular training. Maintenance technicians had last been trained about the need for the gas washes in 1997, 7 years before the incident. The maintenance supervisor, who was authorized to use a password to skip the gas washes, was hired after 1997 and never received the training. So a very important lesson is, be sure personnel are fully trained on process hazards before authorizing them to override automatic systems.
The CSB made several recommendations to the company, government agencies, and others.
Oxidizers are commonly used for reducing air pollution. However, they have been the source of numerous explosions. Our recommendations are aimed at reducing this hazard. Inside an oxidizer, fuel, air, and an ignition source are all present. There is a serious risk if the fuel-air mixture is too concentrated. Facilities with oxidizers should use multiple layers of protection, such as gas monitors, safety interlocks, and alarms, to prevent a single mistake from leading to an explosion. The CSB recommended that the National Fire Protection Association, which creates fire codes used around the country, require additional safeguards to prevent explosions at ethylene oxide facilities. Specifically, we recommended the codes require the use of gas concentration monitoring equipment, alarms, and explosion damage control devices. We also recommended that Sterigenics install similar safety devices and improve its employee training and hazard analysis programs. Finally, we recommended that the National Institute for Occupational Safety and Health, or NIOSH, work with the ethylene oxide industry to promote the use of gas monitoring and other safety measures. CSB recommendations are aimed at preventing accidents. If followed, we believe these recommendations will go a long way towards developing safer workplaces. To read the full report on the CSB's investigation, visit our website at csb.gov. Thank you for watching this CSB safety video.